Alright, let's move on. Now we want to have a look at our symmetry properties. And this is how we can find the value of sine, cos, or tan in any quadrant that isn't the first one. Because when we were looking at our special triangles and at our table of values, you could see that all of our angles were like below 90, right? We had 45, 60, and 30 degrees. So those are all in that first quadrant. However, if we went, instead of just being in this first quadrant, we went to an angle over here, that angle is going to be greater than 90, right? That might be an angle of, like 120 or something. How would we find the sine, cos, or tan of that angle? And this is what we are learning about here. So, the symmetry properties give the relationships between the trigonometric values in quadrants 2, 3, and 4, and that of the first quadrant value called the base with which they are symmetric. So, for any real number theta, where theta is in between 0 and pi 2, or 0 and 90 degrees, the trigonometric point lies in the first quadrant. Other quadrant values can be expressed in terms of base theta. So what this means is we can actually use equivalent angles in the first quadrant to find information about other quadrants, 2, 3, and 4. So, let's go over what this actually looks like in practice. So, say we have our unit circle. That was terrible unit circle, wasn't it? Say we have our unit circle here, right? And we have an angle theta, right? And obviously we're going to have an x value and a y value at this coordinate. If we have an angle over here where the two lines are kind of reflected in the y-axis. Can you see how they're kind of, they're both at exactly the same, or they both look the same. They both look like they've been flipped around that y-axis, right? It's kind of like one of those things you do in primary school, right? Where you kind of paint a butterfly on one side of a piece of paper and then fold it in half and open it back up again, and you have the butterfly wings symmetrically on both sides. That's kind of what it looks like, right? So, if our angles in here are actually the same, so we have theta on one side and theta on the other side, measured from the x-axis, then these coordinates will actually be similar. So we're going to have the negative x of that value. I'll write that a little bit clearer. We're going to have the negative x of that value, right? Because now it's on the negative side. And then we're going to have the same y value because these two coordinates here are symmetrical as well, right? So, this takes a little bit of time to wrap your head around. So if you're struggling a little bit, make sure you kind of go back over the content and really try to understand it. But as you can see, our x values here are going to have the same values, just one's going to be negative, and our y values are going to have the same values. And if you're particularly switched on, you might notice that this follows our system. CAST. Both x and y are positive here, only y is positive here, cos, or x, is negative. Right? So, let's get on to how we can actually use this information to find sine and cos and tan of angles. Say that theta is equal to 30 degrees. Right? And say I asked you to find the cos of 120. I said, look, students, find the cos of 120. Right? You might immediately think 120, that is not on my table of values, that's not on my special triangles. I have no idea how to do that. But what you actually need to do is have a think about if you can use these symmetry properties. So, we know that, right? We know that our two angles here are going to be symmetric, right? If our two thetas are both 30 degrees, right, then this angle, let's get a different color. This angle is going to be 120. So, the cos of 120 is going to be equal to the negative of the cos of 30. So, because we know that these two x values are the same, except one has a negative out the front, we can find the cos of 120. What's the cos of 30? Draw your special triangle or open up your table of values. Remember, we're going to have root 3, 1, 2, 30 is up here. The cos is the adjacent over the hypotenuse, which gives us negative root 3 over 2. And that is going to be the x value right there. Alright. So, that was a pretty standard example. What you can see that we have down here is the kind of formulas for the second quadrant, third quadrant, and fourth quadrant. So you can apply these throughout all the quadrants. So, our second quadrant is pi minus theta. As you can see, pi minus 120 degrees gives us 30 degrees. Or in other words, 180, which is equivalent to pi, minus 120 gives us 30. And so